Afternoon, students. Uh, so today we'll discuss about the powders and their manufacturing methods. So you all know that a product can be made only if you have some raw materials. So in this case, what is the raw material? The raw material is our powder. So powder can be of different types of different materials. We have already discussed in our previous class. It can be of any metal, any alloy, any ceramic, and a combination of metal and ceramic, which is basically your cermet or composite composition. What are the various materials of uh, powder metallurgy products? Which means the powders of different materials. No alloy, you can take alloy of iron, you can have a alloy steel alloys and aluminium powders, aluminium alloys, copper, nickel, brass, bronze. Then you have refractory metals like molybdenum, tungsten, tantalum. These are of high temperature. Then you can have metallic carbides that are tungsten carbide, silicon carbide, etc. So now you have the material selected for your particular application. I have already discussed various applications of automobile, of aircraft application, and for your filtration, for your surgical implants. We have already discussed a brief information about the applications. Then these powders, commercially available powders, are of different, you can say, different types and different particle size. So when you see your powder under a microscope, then you can visualize its particle shape and size. So with the naked eye, you can only see that it is a powder only, but what is the morphology, what is the size, what is the shape, you can analyze it only with the help of a high resolution, high magnification microscope. So, what are the different particle shapes? What are the various possible shapes of powders which are available in the commercial market? So they can be of spherical. They will have some rounded shape. They are also available in the cylindrical and some irregular spongy shape. So these are four basic types which are commercially available in the market. However, some different shapes are also available, like acicular, like flat shape, flaky shape, then cuboid, and some aggregate. Aggregate means the clustered powder, or you can say the agglomerated powder. So what is the conventional powder metallurgy size range of the powder particles which are available for particular different applications? So it ranges between 25 to 300 micron, and easily this powder of this particle size is available in the commercial market. Now, after this, we have different important features of powders which are used in powder metallurgy, and these features have their role in the powder, in the quality, and in the, you can say, the strength and performance of the powder metallurgy compact. So first important feature, or you can say the feature which you have to determine before using it to produce the powder metallurgy product. The first one is the angle of repose. So what is this? Basically, it is the angle formed by a pile of powder as they are poured from a funnel. Okay. So as you can see from this funnel, that there is a funnel shape object, and then you pour all of your powder through it, and then it falls onto the surface, and it forms a heap of powder. So basically, you are interested in knowing this angle of repose. What is the significance of this angle of repose? So the larger angle indicates greater friction between the particles. Okay. And now what is the significance of interparticle friction? So this friction between the particles, it affects the ability of powder to flow readily and pack tightly. So if suppose if the powder particles have larger friction between them, then they are not easily flowable into the die cavity, and they will also pose a problem into the flowing of powder into the powder feeder, and through the from powder feeder to the die cavity through the pipes and hoses. Okay, and the spherical shape reduces shapes results in the lower interparticle friction. So what is the most preferred shape of powder particle? This is basically the spherical shape because it offers the lowest interparticle friction. After this, some important things to discuss in the powder, and these are the packing, the density, and the porosity. So first important term or the property of your powder which you have used to make the powder metallurgy parts, this is basically your true density. So most of you know about what is a true density, but basically it is the density of the true volume of the material, and this is the density when the powders are melted and then they are formed into a solid mass. So in this case you don't have any pores, you don't have any porosity in this solid mass. So the density of this solid mass which is formed by melting of the powder particles, this is basically the densities, this density is your true density. Then you have another density which is called the apparent density, or sometimes it is also known as the bulk density. In the books you will find either the apparent density or the bulk density, and it is the density of the powders in the loose state after pouring from a particular funnel into a particular cavity, and it includes the effects of the pores between the particles. So all the particles are in loose state and they have some pores or the voids between the particles, and because of these pores the apparent density is always less than the true density. So if there is a pore, you know that there is a pore. If there is a pore, then the density of the powder mass which you have taken, it will have a lesser density. And another important factor is called the packing factor. So it is basically the apparent density divided by the true density. And the typical value of this packing factor, it ranges between zero point 0.5 to zero point 0.7. It gives you an idea about it how much of the powder particles have closely packed inside a particular space. Okay, and if the powders of various sizes are present, the smaller particle will fit into the interstices of the larger ones. So while selecting a powder particle size, then there should be a range. All the powder particles should not be of the same size. So you can consider the case then whenever you have all the powder particles of the same size and same space. So how much you compact it, after the compaction you will still have some voids and porosity between the powder particles. But if there is a powder particle size range, it means if you have a powders of very small size and then it ranges also to the bigger size, then while applying the pressure or compaction into the die cavity, these small powder particles will move and it will fills the space or the void between the void or space which is present between the large particles. Question arises that how to measure this apparent density. So this apparent density is basically determined by a special device which is called as the Hall flow meter. So basically in this figure you can see that there is a stand, there is a steel stand, and the top of it there is a base, and then you have there is a measuring cylinder of the known volume, known capacity. Basically the capacity or the volume of this cylinder, this cylinder is 25 ml. So it is basically as per a standard which is developed by some specialized agencies. So they have basically decided this particular volume, and then through this there is a funnel which is known as the Hall funnel, and then you continuously you pour your powder throw into this cavity, and then all the powder particles, they will flow, and then they will fill the this cylinder which is placed at the bottom of this funnel. So now you have the known volume, and then what you will do, you will take the you will measure the weight of this cylinder before and after, and then then subtract it to get the weight of the powder particles, powder which you have selected, and then you have the volume, and through it you can easily calculate the apparent density. Okay, now what is the benefit, or you can say what is the significance of this particular property? So it is one of the most critical characteristic of the powder because of the following reason. The first reason is this, that it determines the size of the compaction tool and magnitude of press motions necessary to compact and densify the loose powder. So what it means then, that if you have apparent density, very less apparent density, then you require a bigger press or bigger tooling to compress the powder particles, and then then to convert this powder mass into a solid compact. Okay, and it determines the selection of equipment used to transport and treat the initial powder. So apparent density, so you know that if the density of the powder is less, then it will also cause a problem in the transportation or the flow of the powder particles into cavity, as well as flow of powder particle from the powder feeder, and from there to the your cavity, and it influences the behavior of the powder during the sintering. So whenever you have a large apparent density, then it means there will be a large volume, and large volume between the powder particles, and it will cause, no matter how you densify it, how much you sinter it, there will always be some voids between them, and it will cause the problem in the sintering process. So after this, another important property is your tap density. So the packing or the density can be improved by vibrating or tapping the powders, causing them to settle more tightly. So what you have one special apparatus which is called the tap density apparatus, and basically it contains this glass cylinder, and then you fill the powder of your known quantity and known mass into this particular cylinder, and then it vibrates and also rotates. So vibration means the tapping. So from this diagram you can easily see what is the effect of number of taps, or the vibration or jolting of these cylinder, and what is the effect in improving its density. So if you see that if you increase the number of taps, then it will also increase the density of the powder which is used to make the powder metallurgy compact. And different, and even if you have different particle size and different shapes, so it will have different effect along with the tapping number of the tapping which is basically you have applied to make the powder particles closely packed with each other. So, if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.